Hello everyone, today we're going to be going over the entire multiple choice section of the August 2022 Algebra 2 Regents exam. We're going to be starting off with question number 1, which says that the Hot and Tasty coffee chain conducts a survey of its customers at its location at the Staten Island ferry terminal. After the survey is completed, the statistical consultant states that 70% of customers who took the survey said the most important factor in choosing where to get their coffee is how fast they're served, right? Based on this result, Hot and Tasty coffee can infer what? Well, automatically I can eliminate choices 1, 2, and 4, right? Because just look at them, right? Choices 1, 2, and 4, all of them make assumptions outside of the environment that was tested in. So what I mean by this is choice 1 says most of its customers in New York State care most about being served quickly, right? How can we make an assumption about every single citizen or every single resident of New York State or every single customer in New York State when we only asked people in the Staten Island ferry terminal, right? Same thing goes for number 2. Coffee drinkers care less about taste and more about being served quickly. How do we know what every single coffee drinker on the planet wants or cares about when we only asked people at the Staten Island ferry terminal, right? Our assumptions need to match the place or the population of the survey, right? So choice number 3 matches this concept best, right? Because it says most of its customers at the Staten Island ferry terminal care more about being served quickly. We asked people about the Staten Island ferry terminal, and 70% of those people said that it was more important how fast they were served. So yes, it is 100% valid to assume that most of the customers at the Staten Island ferry care more about being served quickly. We literally asked them, and we had a majority. That's all. We can't assume that most customers at all transportation terminals care more about being served quickly because we only asked about one transportation terminal, right? So your assumption should relate back to or should match whatever sample you tested for. Right here, we tested people in the Staten Island ferry terminal, and right here, our conclusion or our assumption focuses around the thing that we tested or the location we tested around, right? So moving on to number 2, it says, given that I is the imaginary unit, the expression x minus 2i squared is equivalent to what? In order to solve this, all you're going to have to do is just expand this, right? So I'm going to go ahead and do that right here. X minus 2i times x minus 2i, same thing as x minus 2i squared, right? X times x is x squared. X times negative 2i is negative 2i x. Same thing here, negative 2i x. And then here we're going to have to multiply negative 2i by negative 2i. That's going to give us positive 4 times i squared, right? Because the way we could have done this, we could do this term by term. So negative 2 times negative 2 is 4, and then I times I is just I, right? So we would have gotten 4i squared, right? Now, the value of I is equal to radical negative 1, right? So if we square I, that means that we're also squaring this radical negative 1, right? The square cancels out the radical, so you're just left with I squared is equal to negative 1, right? So if we plug that in, we're left with x squared minus 4 ix minus 4, right? Because we're doing negative 1 times 4, which is minus 4. And here we just combine these two like terms. That gives us 4 as our answer. Number 3 says the equation below can be used to model the height of a tide in feet, h of t on a beach at t hours. Using this function, the amplitude of the tide is what? All we're asking here is just to identify the components of this equation. Easy way to do that, just remember this, that the coefficient of the trig function, or by trig function I mean the sine, the cosine, or the tangent. Whatever's in front of that is going to be your amplitude, right? Whatever you're multiplying t by is going to be your frequency. Whatever you're adding to t or whatever you're adding to x is your phase shift, right? So this is what you're adding to go left or right. And then this plus 5.1 is just the vertical shift. So based on what I just said, obviously our amplitude is going to be 4.8, right? Because it's the coefficient. Great. So moving on to number 4, it says, in watching auditions for a lead singer in a band, Liam became curious as to whether there is an association between how animated the lead singer is and the amount of applause from the audience. He decided to watch each singer and rate each singer on a on a scale of 1 to 10, where 1 is the least animated and 5 is the most animated. He did this for all 5 nights of the audition and found that the more animated singers did receive louder applause. The study Liam conducted would best be described as observational, right? Because all he did was he decided to literally watch each singer and rate them, right? And based on what he saw, that's how he reached his conclusions. He reached his conclusions through an observational study, right? It's not an experiment because he doesn't have an independent or dependent variable, right? He didn't conduct an experiment or anything. He didn't manipulate any variables. All he did was literally he just watched each singer, right, and drew conclusions from what he saw, right? It's not a sample survey because he didn't ask anyone, and it's not a random assignment, right, because he didn't assign anything to anyone. All he literally did was when he went in and he watched them. That's observational, right? Number 5 says in the diagram of a unit circle below, point A, which is negative radical 3 over 2 comma 1/2, represents the point where the terminal side of theta intersects the unit circle. All right, and it's asking us what is the measure of this angle. This one, the key thing here is that it's on a unit circle, right? On a unit circle, let me just rewrite these our coordinates right here. So we have a negative radical 3 over 2 comma 1/2. So this is going to be our x value. This is going to be our y value, right? And on a unit circle, your x value is also equal to cosine, right? So cosine theta and is going to be your x value, and sine theta is going to be your y value, right? So when you're on a unit circle, right, and you're trying to or you move back by angle theta, right? A way to calculate that point, or what that point is literally to go cosine, plug in theta, and that's going to give you your x value, and you can go sine and then plug in your value of theta, and that's going to give you your y value, right? But this only works in a unit circle. So in other words, what I'm trying to get at is we don't really have to do much work other than literally just guess or plug in these values into the cosine or sine function and see which one gives us back negative radical 3 over 2 and 1/2, right? So here I have cosine theta is equal to negative radical 3 over 2, right? You could obviously solve for that. Your theta is going to give you 150 degrees, right? And let's just go ahead and let's verify that right here using our graphing calculator, which you all should have and use. Just remember that you should press mode and then set it to degree for this test. Press enter. All right, so what did I just say? I said that our theta has to be 150 degrees, right? Because if I plug in cosine, right, I go cosine 150, close parentheses, I get this. I get negative 0.866, right? Now, if I go and type in negative root 3 over 2, that's going to give me negative 0.866, right? So that means that our x values match, right? So let's just say I don't trust this method, right? And I'm really skeptical. I could do the same thing for our y value, right? Except I'll have to just plug this 150 degrees into this sine. So let me go ahead and do that right now, right? I have sine 150 degrees, and that's going to give us 0.5, which is equal to 1/2, right? So really, all that I did here was I recognized that it was a unit circle. And then from there, I literally just saw which angle value gives us an x value of negative root 3 over 2 when we plug it into the cosine function, and which angle value also gives us a value of 1/2 when we plug it into the sine function, right? So always, just for this, remember that it's cosine theta comma sine theta, right? Is the same thing as x comma y when you're dealing with a unit circle, right? So number 6 says, consider the function f of x is equal to 2x cubed plus x squared minus 18x minus 9. Which statement is true? Well, they give us an equation here, right? Y, which is and f of x is the same thing as saying y equals. So why don't we just plug this into our graphing calculator before anything, right? I'm going to go ahead and do that right now. So what do we have? We have 2x to the power of 3, right? And then plus, don't mean to type it in there, plus plus x squared, right? Plus x squared minus 18x, right? And then finally, we have minus 9. Here, we're going to graph it. That's our equation. Whatever, leave it alone. Now, let's look. It's asking us which statement is true, so let's go ahead and look at it, right? So it says that 2x minus 1 is a factor of f of x, right? Whenever we see factor, that means that if it has to be a factor, it has to divide evenly into this. And a cool way and a really easy way of checking for that is whatever. It's a two-step equation. It's a two-step process. The first step is we're going to write it down, right? And we're going to set it equal to 0, right? That's number one. Next, we're going to solve for x, right? So if we solve for x here, we add 1 on both sides, then we divide by 2. X is going to have to equal to 2x is 1, right? Divide by x is going to have to equal 1/2, right? So here we have x is equal to 1/2, right? So now that we solve the value, we find the value of x when we set it equal to 0. If this is a factor, when we plug x is equal to 1/2 into the graph, it should give us a value of a y value of 0. And that's how we know that it evenly divides into it. That's how we know that that's a factor, right? Because remember, when you factor something, what you're really doing is you're splitting it into its two zeros, right? If I want to factor like x squared plus 8x plus 4, right? What am I doing? I'm regrouping it into its simplest terms, literally into its zeros. So I think that's, sorry, 4x plus 4, that's going to turn into x plus 2, right? Its zeros are, its 0 is going to be -2, right? So whenever you're factoring something, you're reducing it into the simplest terms, which are often its zeros, right? So we did that right here, right? If this is a factor, that means that when x is 1/2, the entire graph should equal to 0. So let's see if that's true. To test if that's true, I could go ahead, I could press second trace, hit value, and then I could plug in 1/2 and press enter. And it's see, when x is 1/2, right, our y value is -17.5. So it is not a factor because that x value does not yield a y value of 0, right? So moving on to choice number 2, we do the same process, right? X minus 3 is equal to 0. X is equal to 3, right? So let's check if x equals 3 gives us a y value of 0, right? So same process, second trace, value, right? X equals 3. We get a y value of 0, right? Guess what? Because that y value is 0, that means that this has to be a factor, right? Because this process is literally almost never wrong, unless we're dealing with a fraction, right? But we're not dealing with the fraction here. So all we did was we set the factor or the possible factor equal to 0, right? We solved for x, and then we verified that this x value really did give us 0. That's all. Moving on to number 7, it says which sketch could represent the function m of x is equal to negative log 100 times x minus 2, right? So there's pretty much no other way of doing. I mean, unless you know your log rules really well. I think the safest option or safest way to do this is literally just plug it into your calculator, right? You have a graphing calculator. You can graph this. Do it, right? So we have negative, right? And if you need a custom log, right, we can go into math, and then we could scroll all the way down until we see log base, right? So here's our log base. We have negative log 100, right? And then right here we have x minus 2. Boom, we hit graph, and this is what it's going to show us, right? Now, this is a pretty awkward graph, right? We're just left with this kind of this sliver right here, but the graph isn't always perfect. What's happening here is that there's a asymptote right here, and it's not showing us that asymptote, right? If we press second table, all this means is that it's just approaching. Sorry, it's just after this point, it's going all the way up in almost a straight line, and it's never approaching 2, right? It's infinitely approaching 2. And if we look at this right here, right, if I just redraw what I see, essentially what happens is if you have this, right, and then here's an asymptote, so it forever approaches this point but never touches it, and that graph really just matches this, right? It's the only graph that it has to match, right? So I guess the only thing you can get confused here is that asymptote, right? But if you knew and if you know how usually graphing fractions are, graphing logs and exponential functions are, you should know that this is just an asymptote which forever tries to approach 2 but cannot, right? That's all. Moving on to number 8, it says which equation has roots of 3 plus I and 3 minus I. So whenever you have imaginary roots, right, you know that that equation never crosses the x-axis. That's all, right? So before I even start looking at this, right, before I even care to look at this, I should just graph this and see which one of these equations actually touches the x-axis, right? Which one of these actually has imaginary roots and which one actually has real roots. So let's just go ahead and do that. X squared minus 6x plus 10. That's our first one. Here we have x squared plus 6x minus 10. That's our second one. Here we have x squared minus 10x plus 6. And here we have x squared plus 10x minus 6, right? So I'm just going to go hit graph. And automatically, all of these graphs, except for the blue one, cross the x-axis, which means that they have real roots, right? This equation is asking which equation has roots of 3 plus I and 3 minus I. That means that this equation only has imaginary roots, right? It only has imaginary roots, and that means that it will never touch the x-axis, right? Obviously, the blue graph never touches the x-axis, right? And the blue graph is x squared minus 6x plus 10, which is choice number 1. Right? So now we're moving on to number 9. It says local university has a current enrollment of 12,000 students. The enrollment is increasing continuously at a rate of 2.5% each year, which logarithm is equivalent to the number of students it will take for the population to increase to 15,000 students, right? So here we have something increasing continuously, right? And whenever I see this, I want to remember the formula. A is equal to P times E to the power of R times T, right? This is your value, your final value. This is your principal or initial. This is just the symbol E, right? This is your rate, and this is your time, right? So here what's happening is we're trying to find T based on this, right? So first of all, let's set up this equation, right? We have A is equal to 12,000 students, which is our initial, right? And then we have E, which means it's continuously increasing at a rate of 2.5%, which is the same thing as saying 0.025, and then X or is our time, right? Or T is our time, whatever. Now it's saying that how long will it take for this equation, right? What's the value of X when A is 15,000, right? So all you have to do is just set this equal to this. That's all, right? A is your value after time, right? And our value after a certain amount of time was 15,000. All we have to do now is just solve, right? So in order to solve this, first step I'm going to have to do is just divide by 12,000, right? I want to get X on its own. First, I'm going to have to divide by 12,000. So now I'm left with 15 over 12 with a bunch of those zeros, right? Now, obviously, once I do that, I'm just going to be left with E to the power of 0.025x, right? In order to get rid of this E, I'm going to have to find a natural log on both sides, right? Natural log. Remember that the natural log of E to the power of x is just going to give you x, right? It's just going to give you your exponent, and these two are going to cancel one another out, right? And remember that whatever I do to one side, I have to do to the other side, so I have to find the natural log of this side, of this entire thing only, right? So I'm going to find the natural log. Next, I'm going to be left with the natural log of 15,000 over 12,000 is equal to 0.025x, right? Because they just canceled out, so 0.025x. And then I'm going to have to divide this entire thing by 0.025 in order to cancel out this x and just get x on its own, right? Now you may be thinking, oh no, this choice doesn't match anything here. That's simply because they actually simplified 15,000 over 12,000, right? So I'm going to go ahead, I'm going to simplify that too because I'm just too lazy, right? Actually, you know what? The answer is going to be choice number 4, right? Because if we think about it, you get rid of these zeros, right? You're going to be left with 1.25, right? And you're dividing by that. So 4 is going to be your answer. Moving on to number 10, it says that what is the total number of points of intersection of the graphs of the equations y equals e to the power of x and xy is equal to 20, right? So it's asking you for intersection, and it just gave you the equation of two functions, right? Remember that you can always graph these on your calculator, and your calculator even has a special button to see the total amount of intersections, right? So I'm going to go ahead, I'm going to put them in terms of e before I graph them. So y is equal to e to the power of x is already in terms of y. And now I just have to turn yx is equal to 20 in terms of y. So all I have to do is just divide by x on both sides. I get y is equal to 20 over x because these x's cross out. Y is equal to 20 over x. That's all. Now I'm going to have to graph these plug these into my graphing calculator, right? So I'm going to clear all of my other functions, and I'm just going to plug in e to the power of x, right? I'm going to scroll down, and the next thing I'm going to plug in is 20 over x. I'm going to hit graph, and I'm going to see how many times they intersect, right? So off the bat, I see one intersection here, but let's just say I'm skeptical, right? I can always go zoom out, and once again, I see that they only intersect once and once only. That's it. Right, and you may be saying, oh, but they follow the same line here. That's an asymptote, right? Which means that they never truly touch that point. They're gonna forever approach that point, but never, right? And we can verify this if we just go back and look at our table, right? I see no point at which they even try to intersect, or which any of these 2 points match, right? So that's all. So number 11 says the amount of substance A of t in grams remaining after t days is modeled by A of t is equal to 50 times 0.5 to the power of t over 3, which statement is false, right? So once again, we're given a function. So let's just go ahead and first let's graph it, and then let's see which one is true, which one is false, right? So I'm going to go and I'm going to press 50, right? Parentheses 0.5, and I'm going to raise this to the power of x over 3, and I'm just going to go hit graph. I'm also going to set my zoom to standard. Actually, maybe that wasn't a good idea. Maybe I'll just zoom out, right? Except I'll zoom out about here. So here's our function, right? It's saying that in 20 days there's no substance remaining, right? So this is saying that when t is 20, y should equal to 0. Let's see that, right? We could easily verify that with our table. Right, so if we go second graph into our table and we head down to 20, right, this automatically we know that this statement is false because after 20 days there's still 0.49 grams of the substance remaining, right? This should be 0 if this was true, but it's not, right? It's false, and we're looking for the false choice. That's all, right? So number 12 says the parabola has a vertex at 1, 2 and a focus at 2, -3, and it's asking us what equation it has, right? So first off, I'm gonna plot out the situation, right? Here we have a vertex of 2, 1, right? So here I'm gonna write 2. Actually, that ugly tick marks, I'm gonna make them a bit smaller, right? So I'm gonna go 1 tick mark, 2 tick marks, right? And then I'm just gonna go up by 1, right? So here's our vertex, and we have a focus of 2, -3, right? So here it's also 2, but here we go 1, 2, 3, so -3 down, right? And here's our focus. Remember that your focus and your directrix, your vertex lies between them. So our directrix is going to have to be somewhere up here, right? But also remember that the distance between your vertex and your focus, right? I don't know why it's not drawing right now. That's strange. Oh, all right. Anyways, the distance between your vertex and your focus is always going to be p, right? So we can go ahead and we could determine that, right? Okay, it's deciding to respond, right? So vertex to focus is going to be just 1p, right? And the distance from the vertex to the directrix, right, which is going to be this line right here, is also going to be p, right? So if the y value of our vertex is 1, right, and the y value of our focus is -3, it's obvious that p is equal to 4, right? And that our directrix is going to be y is equal to 5, right? Because if we go 4 up from 1, if we go 4 down from 1, we get -3, which is our focus, right? And if we go 4 up from 1, we get 5, which is where our directrix is going to lie, right? And now that just know that your graph can never intersect the directrix. So really, we're going to open downwards. And that's all, right? So now that we know what our p-value is, and now that we have the entire graph situated, we know that the coefficient is going to be negative. So automatically we can eliminate choice 1, right? We know that it's going to be negative. It's going to open downwards, right? Now, I could worry... just remind yourself of the vertex form, right? These are vertex form equations. It goes y is equal to your a value, right, times x minus h, right, squared plus k, right? And h comma k is your vertex. So if our vertex is 2 comma 1, our h value is going to equal to 2, and our k value is going to equal to positive 1, right? So which equation has this correct? It's obviously going to be choice number 3, right? Because here you have x minus h, so x minus 2, right? Because that's just minus h. And here you have a k value of just regular 1, right? Because plus 1 and your k was 1. That's all. So honestly, in essence, you didn't even need to know all this. I was just playing it safe, right? But really, you just needed to know how to plug all of this in. And that's all, right? And you know that a is the, oops, didn't mean to draw that. You could also just know, in order to solve for 1/16, you know that a is equal to 1 over 4p, right? So this would have been negative 1 over 4 times 4, which is negative 1 over 16, right? That's how we got that. 13 says the expression a times root 3 2b squared times root 3 4a squared times b is equivalent to which of the following? Let's go ahead, let's try solve for that right now. Right, so a root 3 times 2b squared, right, times root 3 4a squared b, right? So whenever you're multiplying these two things, just know that you could literally just combine these all under 1 root 3, right? Because since your root is matching in value, the value of this root is 3. It's a cube root, right? So you could just leave a alone, right? And then you could write everything else underneath this root down, right? So you're going to be left with 2b times 4a squared b, right? And that's going to give you, if you actually multiply those out, that's going to give you root 8 b squared b cubed a squared, right? Because the 2 and the 4 are going to combine the b squared, sorry, I forgot to write this b. The b squared and the b to the first power are going to combine. You're going to add those two exponents, and you're going to just be left with the a squared, which you just left alone and didn't touch, right? So now you have a root 3, 8b cubed times a squared, and now we're just going to start simplifying this, right? So a cool way of simplifying this is just to write it down individually, right? So write each term down individually. So root 3 of 8 times root 3 of b cubed times the root 3 of a squared, right? Because remember, we just the same way that we combined everything under 1 root 3, right, under one hat, we can separate into many hats being multiplied by one another. We know that the cube root of 8, right, or which number multiplies 3 times into 8 is 2, right? So we can just write that as 2a. Next, we're going to be multiplying this by the cube root of b cubed, right? These two are going to cancel out because b times b times b is equal to b cubed, right? And we're trying to find what that is, right? So that's just 2ab. And 3, the root 3 of a squared is just going to stay the root 3 of a squared, right? Because it's not a perfect cube. So which choice properly matches that is going to be choice number 1. So moving on to number 14, it says given x to the power 3 to the power of x minus 1 plus 2, as x approaches infinity, as negative infinity, what happens to our y, right? So literally all we have to do to solve this is just plug it into our calculator, right? So here I'm going to write 3 to the power of x minus 1. I'm just going to add 2. I'm going to hit graph. I'm going to reset my zoom. And that's all, right? Next, I'm going to go into my table, and I'm going to actively scroll down to negative infinity, right? Negative infinity means that the x is decreasing, right? So as I decrease my x to negative sector or negative section, I know that my y value keeps approaching 2, right? I keep going forever and ever and ever and ever and ever, and my y value is always going to be 2, right? So the answer to this is choice number 3. If I go, number 15 says, for all values of x for which the expression is defined, x squared plus 3x over x squared plus 5x plus 6, that is equivalent to what, right? So all you have to really do for this one is just divide, really. So here we have x squared plus, actually, you could divide, right? There's two ways to do this. I just thought of a second way to do this, right? The first way is to divide it, right? And that you're gonna have to do x squared plus 5x plus 6, and then you write this in here, right? But a much easier way to do this is just to factor it out and then just cancel out, right? So I can factor the x out from x squared plus 3x, right? And I'm left with x plus 3, right, as our numerator. And I can factor x squared plus 5x plus 6. I'm looking for a number that multiplies to 6 and adds to 5. That's going to be 2 and 3. So I'm left with x squared plus 2x plus 3x plus 6, right? I'm going to factor out my x. I have x plus 2. Factor out my 3. I have, right? And if I factor out my 3, I'm left with x plus 2, right? So here I have x plus 3 times x plus 2, right? These two are going to cancel out. I'm going to be left with x over x plus 2, which is choice number 2. Moving on to 16, it says a recursive formula for the sequence 64, 48, 36 is which of the following, right? So in order for something to be recursive, I need the a sub n, right? I always need a sub n to be defined, right? Or a minus 1 to be defined. So automatically I can eliminate choices 3 and 1 because they don't have what a of n and the previous term is, right? In order for a recursive formula, you need the previous term, right? And the previous term is always defined by a sub n minus 1, right? This gives you the previous term. That's all, right? So we're looking for the two equations that actually have that a sub n minus 1, right? And next, we're going to see if this is a recursive formula is arithmetic or if it's geometric, right? How do we find that? We need to see if either we're adding the same value for all of these, or if we're actually multiplying them by something. Well, automatically we can see that we're multiplying something, right? Because in order to go from 48 to 64 to 48, right? Let's go ahead, let's calculate that right now. 64 to 48, so 64 minus 48, right? That's 16, right? So we minus 16. Next, to go from 48 to 36, right? 48 minus 36, right? That's going to be 12, right? So if we go to here, that's minus 12, right? So automatically, this is not arithmetic, right? You're gonna have to multiply by 0.75 for each one, right? Because subtracting 16 is going to give you the wrong answer. Subtracting 16, with each successive term, you don't subtract 16, you subtract a different number, right? So choice number 4 is the only thing that represents that. 17 says, which expression is equivalent to x cubed minus 2 over x minus 2? All we have to do here, unlike the other one, I see no way we can factor this out, so we're just going to have to divide. Right, so I'm going to write x minus 2 down there, x cubed plus 0x squared plus 0x minus 2. Right? Remember to substitute those values in, so it's in standard form. Next, I'm just gonna divide as usual, right? So x goes into x cubed, x squared times, right? So x cubed, right? Negative 2 times x squared is negative 2x squared. I subtract these. I'm gonna get left with positive 2x squared plus 0x, right? I'm gonna bring that down. How many times does x go into positive 2x? It goes into 2x, it goes there 2x times, right? That's going to be 2x squared minus 4x, right? Subtract them, I'm going to be left with 0. Here I'm going to be left with 4x minus 2, and this goes into here positive 4 times. And right here I can pretty much stop dividing because the only answer choice that actually has that x squared plus 2x plus 4, x squared plus 2x plus 4 is choice number 2. That's all. Right here we have that x squared minus 2x, which is wrong. Number 18 says, what is the solution of the set? What is the solution set of the that meant to be an eraser, sorry. What's the solution set of the following equation? So straight off the bat, I can, I know that we're dividing by something and we have these variables, right? So I know that we cannot divide by 0, so we know that k cannot equal to 6, and we know that k cannot equal to 2, right? So anything that has 2 and regular 6 we can cross out, right? So choice number 1 we're crossing out. Next, we can just divide this as usual and solve it for it as usual, right? We know that k squared minus 8k plus 12 is the same thing as saying k minus 2 times k minus 6 if you were to factor it out, and this is equal to k over k minus 2. The greatest common factor, I want everything to be under the same denominator, so I'm going to multiply this by k minus 6, I'm going to multiply this by k minus 6, and then I'm going to add this to 1 over k minus 6, and I'm going to multiply this by k minus 2 times k minus 2, right? And when I have everything under the same denominator, right, I can just cross it all out. So now I'm left with 4 is equal to k times k is k squared, right? K times negative 6 is negative 6k, right? And we're going to add that to plus k minus 2, right? So 4 is equal to k squared plus 5k minus 2. Subtract the 4. We're left with k squared is equal to 0 is equal to k squared plus 5k minus 6, right? And if we want to find the solution set, we're just going to factor this out and find the zeros. What multiplies to negative 6 but adds to positive 5? That's going to be 6 and negative 1, right? So I could rewrite k squared plus 5k minus 6 as k squared minus k plus 6k minus 6, right? I could factor out k, I'm left with k minus 1. Factor out 6, I'm left with k minus 1. So here I have k plus 6. And here I'm left with k minus 1, right? But remember, I said that our solution cannot, right? It cannot be negative 6 or 6, right? So we're just going to be left with our solution of negative 1 only, right? That's all. So moving on to number 19, it says given the polynomial identity x to the power of 6 plus y to the power of 6 is equal to all this, which equation must also be true for the values of y and x, right? In order to solve this equation, you could either assign x value of 2 or a y value of 3 and just plug it in for all of these, see which ones match up, or you could just expand it manually on your own, brute force it. I already went and did that, and I can tell you that the answer choice is choice number 1. You could have, distributed all of this out, or you could have plugged in values to get that, right? Number 20 says p of theta is equal to 3 sine 1/2 theta on the interval of negative pi is less than theta, which is, negative pi, theta is greater than negative pi, but less than pi. The function p does what, right? So it gives us an interval, which means that it gives us the x interval, and it's asking us what do we do throughout this interval, right? So the only way we can actually figure this out is just to graph it on our calculator, right? So we're going to write 3 sine 1/2, and theta, in this case, 1/2 theta, we can just plug that in as x, right? And then we can go into mode, and we can turn on radian mode, right? Because we're dealing with radians, aka pi, negative pi, and pi, right? So now that we're dealing with radians, we can hit graph, and don't be tempted to say decrease then increase or increase then decrease, because we have to assign that that interval, right? So if the interval, our minimum x value in that interval is negative pi, we're going to go ahead and write that. So here's negative pi, right? And our x maximum, or our limit to our interval, is just going to be regular pi, right? So here I'm just going to clear that, and I'm just going to go ahead and type in pi. Then I'm going to go hit graph, and from this interval that it showed us, right, we can see that it's continuously increasing, right? It's going up, and it's continue going up, right? So it's increasing throughout the entire interval. Number 21 says a company fired several employees in order to save money. The amount the company saved over a period of 5 years following the loss of the employees is shown in the table above. Which expression determines the total amount of money saved by the company over 5 years? Right? So if we want to know the total amount saved over 5 years, I want to know the sum of this. Right? And straight off the bat, I can tell that this is a geometric sequence. Why? Because it's not increasing by the same amount each time, right? To get from 59,000 to 64,000, you're adding by a different amount. To get from 64 to 71, you're adding by a different amount. You can just eyeball that, right? So what's going to happen here is you're going to have to find the sum of a geometric sequence, right? And that choice, that's going to reflect choice number 1, right? So obviously, what you could have done was you could have literally just plugged in 5 for n for all of these, right? For these summations, right? And you could have said that whichever value of 5 gives you 86,000 or 86,381 would be your right answer, right? So if you were just to plug that in, you would have known that both of these values, both of these summations give you something else, right? And choice number 1 is the only thing that actually gives you a value, a value that is the sum of all of this in the end, right? And we know that that choice number 2 is just wrong straight off the bat because it's saying that our rate or our R is less than 1, right? Which would mean that the amount of saved is decreasing per year, but in reality it's increasing, right? So you could have also used that to eliminate 2 and 4. That's all. Number 22 says a rush hour commuter train has arrived on time 64 of its first 80 days. As arrivals continue, which equation can be used to find x, the number of consecutive days that the train must arrive on schedule to raise its on-time performance to 90 days, right? So the answer to this is obviously going to be choice number 2. If x is the amount of days that it remains on time, right? Remember the way that this percentage is, it's the number of days that it arrived on time over its total amount of days, right? So if it arrives on time the second day, right, you're going to have to add 1 to the amount of times that it arrived on time, right, in addition to the amount of total trips, right? So it's going to be 65 over 81, right? And if it arrives on time again, you're going to have 66 over 82. Remember that each time it arrives on time also counts as another trip in total, which is what your denominator is. So you're going to have to add to both the numerator and the denominator. Right? So number 23 says, given that f of x is equal to negative 2 over 5x plus 4, which statement about the inverse function is true? Right? So first off, we're going to have to find the inverse function, right? The way we find it is just flipping the x and y values, right? So here I'm going to write y is equal to negative 2 over 5x plus 4, right? That's the normal function. To find the inverse, I'm just going to write x where y is and y where x is, right? So here I'm going to just flip the values. So x is equal to negative 2 over 5 y plus 4, right here I'm going to have x minus 4, subtract 4 on both sides, is equal to negative 2 over 5y. I'm going to multiply by negative 5 on both sides. I'm going to be left with negative 5x plus 20 is equal to 5y. Sorry, is equal to 2y. Right, I'm going to divide by 2 on both sides, right? So this is going to be our formula. Our total formula is going to be y is equal to negative 5 over 2x plus 10, right? So given that, let's see which choice is true. Obviously, it's number 1 and 2 are eliminated, right? Because it still has a negative slope. So now we're just dealing with it passing through specific points. The best way we can do this is just graphing it, right? So we're going to go ahead and graph our new inverse function. We're going to go negative 5 over 2x plus 10. I'm going to go ahead and graph this. I'm going to go second table, and I'm going to, I don't know why it started us off that, but I'm going to scroll down to our choices, right? So first it says it passes through point 6, negative 5. So if I don't see that on this table, if I don't see 6 in this column and negative 5 right next to it, that means it's wrong. So here I scroll down to 6, and 6 and negative 5 are 2 points on this, right? So that means that this is true. it has a y-intercept at 0, -4 would not be true if you looked at the graph, right? 24 says the amount of substance A of t that remains after t days can be given by the equation A of t is equal to A of 0 times 0.5 to the power of t of 0.083, where A of 0 represents the initial amount of the substance. An equivalent form of this equation is what, right? So all you could do is you can graph each and every single one of these choices, and whichever graph matches this graph is going to be your right answer, right? So what I mean by that is I'm just going to go ahead and do that, right? So here I have 0.5 raised to the power of x, or t, over 0.0803, right? I'm going to plug in our second one, which is well, actually, first off, I'm going to assign just a random value to A. So let's just say that A is 200 grams, right? So here I'm going to insert a value of 200, right? And I'm going to do the same thing for everyone else, right? I'm going to write 200, 0.000178 raised to the power of x, or t, right? Here I'm going to write 200 times 0.9456861 raised to the power of t. Here I'm going to have 200, right, times 0.0415, right, so 0.04015 raised to the power of x. And here I'm going to have 200 times 1.08361 raised to the power of x, right? Then I'm going to go ahead and graph it. So right off the bat, if you didn't catch that, I'm just going to go ahead and I'm going to zoom standard, right, so we can see this even better. If we just look at what they're graphed, the red graph immediately went over the blue graph, right? And if we go into our table, right, the red and blue graphs, right, have the exact same values in the table, right? They match perfectly. What that means is that y1 and y2 are the same, right? So if this is our original equation, that means that our red equation, or y2, right, which is this, is equivalent, right? And that's 24 completed, right? That's all 24 questions of the multiple choice section done. If you have any questions, or leave them down. If you have questions or suggestions on what you want me to review next, or if you have any questions about this review itself, please let me know in the comments. If you like what you saw, please leave a like, and if you want more videos like this, please subscribe to this channel. It really helps in the future, right? So once again, that was all of Algebra 2. I hope you guys learned something, and I hope you have a nice day. Goodbye.